So students, today we are going to discuss the last exercise of this chapter, integrals. Okay, that is exercise 7.11. Now in exercise 7.11 you are given to evaluate the integrals by using properties. Okay, so at first we will discuss the properties and then we will start the exercise. Okay, so the first property is integration of a to b f of x dx is equals to integration of a to b f of t dt. That means if the variable of the function changes, then also you'll get the same answer. Okay, suppose integration of a to b sin x dx you find, integration of a to b sin t dt you find, and you will get the same answer. Okay, next number 2 is integration of a to b f of x dx is equals to minus of b to a f of x dx. You see here the lower limit and upper limit interchanges. Okay, here lower limit is a and upper limit is b. So if you change the limit, if that is the upper limit is becoming the lower limit and the lower limit is becoming the upper limit now, then what you have to do, you have to insert a negative sign. Okay students, and from here you'll get one property, integration of a to a f of x dx is equals to 0 when upper limit and lower limit are same. That means obviously after subtracting you will get the same answer, hence it will be equals to 0. Okay, next number 3, integration of a to b f of x dx. This can be written as the sum of two different integrals. And what is that? Integration of f of x dx, integration of f of x dx. Okay, fine, but you see the limit is what? From a to b. So a to b, and here I am inserting another limit. Okay, that way you can remember a to c, c to b, f of x dx plus f of x dx. Next number 4, integration of a to b f of x dx is equals to integration of a to b f of a plus b minus x dx. So when you find the integral of this and take the original function and find the integral, you will get the same answer. Okay, next number 5, integration of 0 to a f of x dx is equals to 0 to a f of a minus x. So when you find f of a minus x, when you find f of x dx, taking the lower limit and upper limit to be equals to 0 and a, you will get the same answer. And this is important, this will be frequently applied. Okay, when we start the exercise. Next is integration of 0 to twice a f of x dx is equals to 0 to a f of x dx plus 0 to a f of twice a minus x dx. So when you add two integrals whose function are f of x and f of twice a minus x, then you will get that to be equals to f of x dx, integration of f of x dx whose lower limit and upper limit is equals to what? Twice a. Next one, that is number 7 and 8, these are also important, it will be frequently applied. So number 7 is 0 to twice a f of x dx is equals to twice 0 to a, this 2 we have to write it here, 0 to a f of x dx, provided if f of twice a minus x is equals to f of x. So this condition you have to check. If you are getting it to be equal, then you will write 2 integration of 0 to a f of x dx. But another condition is there, if you get f of twice a minus x to be equals to minus of f of x, then this integral will be equals to 0. Okay, so student, what happens if you know the properties, then quickly you will get the answer. Okay, you can apply the properties and then without doing a long method you can easily get the answer. Okay, that is why it will be very fruitful if you know the properties. Okay, next number 8, number 1 is here again two conditions are there. Okay, so integration of minus a to a. So if the limit is minus a to a f of x dx, then if f of minus x is equals to f of x, that means if the function is even function. What kind of function is it? Even function. Okay, so if the function is even function, then integration of minus a to f of x dx will be equals to what? 2 integration of 0 to a f of x dx. And if you get f of minus x to be equals to minus f of x, and what does this imply? This implies that the function is an odd function. Okay, so if you get odd function, then minus a to a, integration of minus a to a f of x dx will be equals to what? 0. Okay, so whenever you get any question which consists of these two properties, then you check the function, then directly you will get the answer. Okay students, so these were the properties you have to keep in mind. Try to memorize it. So next we will start the exercise. Okay, so students, the first question is integration of 0 to pi by 2 cos square x dx. Now I have already given the property integration of 0 to a f of x dx is equals to what? Integration of 0 to a f of a minus x dx, and I told you that that property will be frequently applied. Okay, so we'll apply that. For that we'll take this integral to be equals to I. Okay, let I be equals to this, and let this be equation 1. Next we'll apply the property. So after applying the property you'll get 0 to pi by 2 cos square a minus x. What is a here? Pi by 2. So pi by 2 minus x dx. So 0 to pi by 2 cos 90 minus x. Cos 90 minus x is equals to what? Sin x. So it will be equals to sin square x. 0 to pi by 2 sin square x dx. And let this be equation 2. Now we will add equation 1 and 2. Okay. So adding 1 and 2, you'll get the left hand side to be equals to I plus I, that is equals to twice I. So twice I is equals to integration of 0 to pi by 2 cos square x plus integration of 0 to pi by 2 sin square x. Now here you see one thing, you can combine this and write it as sin square x plus cos square x. So combining both, I'll write it as 0 to pi by 2 sin square x plus cos square x, which is equals to how much? We know that is equals to 1. So 0 to pi by 2 1 dx, that is equals to x. Now substitute the limit. So upper limit minus lower limit will give you pi by 2 minus 0, that is equals to pi by 2. So you are getting twice I to be equals to pi by 2, and hence the value of the integral after applying the property, you'll get it to be pi by 4. So this is how we solve or evaluate any integral using the properties. Okay students. Now question number 2 is also of same kind. It is given 0 to, it is of the form 0 to a fx dx, that will be equals to how much? Same as this, it will be 0 to a f of a minus x dx. So a is again equals to pi by 2, so which you have to substitute here, here and here again. So we'll take this to be equals to I, and let that be equation 1. Now applying the property, you will get integration of 0 to pi by 2 root over sin pi by 2 minus x. So sin pi by 2 minus x divided by root over sin pi by 2 minus x plus cos root over cos pi by 2 minus x. That is equals to 0 to pi by 2 root over, what is sin 90 minus x? That is equals to cos x divided by root over sin 90 minus x cos x plus root over cos 90 minus x, that is equals to sin x. So I will be equals to this, and let this be equation 2. Now adding 1 and 2, so you'll get left hand side I plus I, that is equals to twice I, which is equals to right hand side, you add it up. Numerator is what? Root over sin x plus cos x. Denominator is also equals to root over sin x plus cos x, which will get cancelled. So integration of 0 to pi by 2 root over sin x plus cos x root over cos x divided by root over sin x plus root over cos x dx, which will get cancelled, and you will get it to be equals to 1. So integration 0 to pi by 2 dx is equals to, here again you will get x from 0 to pi by 2. After substituting the limit, you will get pi by 2 minus 0, that is pi by 2. So you are getting twice I to be equals to pi by 2. That means here again the value of the integral will be equals to how much? Pi by 4. Okay students, I hope you have understood both the questions. They are of similar pattern, and still if you have any doubt, then do share with me. Okay students. Now the next question you see, that is question number 5. Here it is of the form minus 5 to 5 modulus of x plus 2. Now it's a modulus function, right? And we know that modulus function, that is modulus of x, is equals to x when x is greater than equals to 0 and minus of x when x is less than 0. So you have to apply this definition of modulus function, okay, in order to find the integral. Now the thing is, what is the value of x here? X is equals to x plus 2. That means two cases you will get. Either the value of the function, now replace x by x plus 2 throughout. So modulus of x plus 2 will be equals to how much then? X plus 2, when x plus 2 is greater than equals to 0, that is x is greater than equals to minus 2, and minus of x plus 2 when x plus 2 is less than 0, that is x is less than minus 2. So for x greater than minus 2, the value of the function is x plus 2, and for x less than minus 2, the value of the function is minus of x plus 2. Now this function is divided into two values. Now how will you write that? So one property I have given, integration of a to b fx dx is equals to integration of a to c f of x dx plus c to b f of x dx, where the value of c will be equals to what? Minus 2 here. So the integral minus 5 to 5, that is the lower limit and upper limit, will be divided into two parts, that is a to c, c to b, where a is equals to minus 5. So minus 5 to minus 2, you'll get one case where the value of the function will be this, and next will be, this is less than minus 2, right? So minus 5 to minus 2, here the value of the function will be minus x to 2, and next comes minus 2, greater than minus 2, right? So minus 2 to 5, for that the value of the function will be this, okay? So applying the property, the given integral will be equals to minus 5 to minus 2 modulus of x plus 2 plus minus 2 to minus 5 modulus of x plus 2. Now you substitute the values according to the limit, okay? Now here you see it lies within minus 5 and minus 2, that is less than minus 2. For x less than minus 2, the value of the function is what? Minus of x plus 2. So minus 5 to minus 2 minus of x plus 2 dx, and from minus 2 to 5, that is greater than minus 2, for x greater than equals to minus 2, value of the function is x plus 2 dx. Now integrate it. So integration of x we know that is equals to x square by 2 plus integration of 2 is equals to twice x, and here the limit is from minus 5 to minus 2 plus integration of x plus 2 is x square by 2 plus twice x, and here the limit is minus 2 to 5. Now substitute the limits, you'll get the answer. So minus, so we substitute the upper limit first. So upper limit is equals to how much here? Minus 2. So put x equals to minus 2. So you'll get minus 2 whole square, that is equals to 4. 4 by 2 is equals to 2 plus 2 into minus 2, that is equals to minus 4. Okay, let me write it here itself. So 2 minus 4 minus lower limit. Lower limit is equals to how much? Minus 5. So minus 5 square is equals to 25 by 2 plus 2 into minus 5, that is equals to minus 10. So we have substituted the limit in the first function. Next you substitute in the second one, plus here the upper limit is equals to how much? 5. So 5 square, that is 25 by 2 plus 2 into 5, that is equals to 10, minus lower limit is equals to minus 2 square by 2, that is 4 by 2, which is equals to 2 again, plus 2 into minus 2, that is equals to minus 4. Now what you will do is you open the bracket. So minus 2 minus 4 minus 25 by 2 minus minus plus 10 plus 25 by 2 plus 10 minus 2 plus 4. Open this bracket again, so you'll get minus 2 plus 4 plus 25 by 2 minus 10 plus 25 by 2 plus 10 minus 2 plus 4, and check whether any term cancels or not, okay? So minus 2 is equals to minus 4, so minus 4 will get cancelled with one of the 4 here, okay? minus 10 plus 10 got cancelled. 25 by 2 plus 25 by 2 is equals to how much? 50 by 2, that is equals to 25. So 25 plus 4, that is equals to how much? 29. Okay students, I hope this question is clear. So in this exercise, one or two more questions are there based on this modulus function. So this way you have to proceed, okay? That is, you write the definition of the modulus function, that modulus of x is equals to x when x is greater than equals to 0 and minus of x when x is less than 0. And accordingly, at the end, what you will do is just substitute the function. In place of x, replace it by x plus 2 throughout. Then you will get the condition accordingly. You arrange the limit and then apply the property. Okay students, a few more questions we are going to discuss now. Okay. So the next question which we are going to discuss now is integration of 0 to pi by 4 log of 1 plus 10x. So here again it is of the form 0 to a f of x. Okay. So apply the property, you will get 0 to a f of a minus x. So let's proceed. Let this be again equals to I and this be equation 1. So after applying the property, so you'll get 0 to pi by 4 log 1 plus 10 pi by 4 minus x. Now you apply the formula of 10 of a minus b. Hence you'll get 0 to pi by 4 log 1 plus 10a minus 10b. 10a, that is 10 pi by 4. We know that is equals to 1. So 1 minus 10x divided by 1 plus 10 pi by 4 10x. 10 pi by 4 is again equals to 1 into 10x will be equals to 1 plus 10x. Now you take LCM. So after taking LCM, you'll get denominator is 1 plus 10x and numerator will be 1 plus 10x plus 1 minus 10x. And here plus 10x minus 10x will get cancelled. So you'll get log 2 divided by 1 plus 10x. Now you apply the property of log. So log a by b is equals to what? Log a minus log b. So this part will be equals to 0 to pi by 4 log 2 minus log 1 plus 10x. And we will take this to be equation 2. Okay. Now adding 1 and 2. So adding 1 and 2, left hand side will be equals to I plus I, that is equals to twice I. And right hand side you see what you are getting is pi by 4. And right hand side what you are getting is log 1 plus 10x. Which on adding with this right hand side you will get log 2 minus log 10x, log 1 plus 10x, that means plus log 1 plus 10x minus of log 1 plus 10x will get cancelled. So you are left with only log 2. Okay. So twice I will be equals to 0 to pi by 4 log 2. And what is log 2? Log 2 is a constant term. So while integrating, before also I told you if you get a constant term you will write it first. So log 2 you will write an integration of what you will get, then you are left with only 1. So from here you will get log 2 x 0 to pi by 4. So substitute the value of x to be equals to pi by 4. So you will get log 2 pi by 4 minus 0, that is equals to pi by 4 log 2. So you are getting twice I to be equals to pi by 4 log 2 and hence I will be equals to how much? Pi by 8 log 2. So pi by 8 log 2 is the final answer. Okay students. Now moving on to the next question, that is number 10. It's again of the same form, 0 to pi by 2, 2 log sin x minus log sin twice x. But here what you will do, the given function we will convert it to more simplified form and then we will apply the property. Okay students. So 0 to pi by 2, 2 log sin x can be written as log sin square x, right students? It can be written as, you see, log a to the power m is equals to what? M log a. So it is given in the form m log a, which can be written as log a whole to the power m. That is sin x whole square, which is equals to what? Sin square x minus log sin twice x, that is equals to 2 sin x cos x. So I am writing sin twice x itself here. Next you see log a minus log b is equals to what? Log of a by b. So we will apply the property. So you will get 0 to pi by 2 log of sin square x by Sin twice x is equals to how much? 2 sin x cos x. So 2 sin x cos x dx. Now here you see one thing, sin x will get cancelled with one of the sin x here. So you're left with sin by cos and 2. So sin by cos we know that is equals to 10. So 0 to pi by 2 log of 10x by 2. Now what will I do is I'll apply the property of log again. Log of a by b is equals to log a minus log b. Why? You see, if you write log a minus of log b, then integration of log 2 just now we have done. Okay, and log 10x we will find the value of that by applying the property. Okay, so this is equals to 0 to pi by 2 log 10x minus 0 to pi by 2 log 2 dx. Let this be equals to I1. So I1 equals to 0 to pi by 2 log 10x, and this be equation 1. So you apply the property. So in place of x, this will be equals to how much? Log of 10 pi by 2 minus x. So you write that step, okay? And we know 10 90 minus x is equals to how much? Cot x. So 0 to pi by 2 log of cot x, and let this be equation 2. So adding 1 and 2, you'll get I1 plus I1, that is equals to twice I1, which is equals to 0 to pi by 2, and after adding the right hand side you'll get log 10x plus log cot x. We know log of a plus log of b is equals to what? Log ab. So log ab, that is 10x into cot x, and 10x cot x is equals to how much? That is equals to 1. So integration of 0 to pi by 2 log 1. And what is log 1? Log 1 is equals to, we know that is equals to 0. So I1 is equals to 0. So this part is equals to 0. So 0 minus log 2 integration of 1, that is equals to x 0 to pi by 2. So substitute x equals to pi by 2. So your final answer will be minus pi by 2 log 2. Okay students, let's move on to the next question then. Now the next question is of another kind. So here it is of the form the integration of minus a to a f of x dx. So if you get any question where you are getting integration of minus a to a f of x dx, at first you have to check whether the function is even or odd. If it's an odd function, then the value of the integral will be directly equals to 0, and if it's not, then this will be equals to how much? Twice 0 to a f of x dx. So our first step is to check whether the function is even or odd. Okay, so here the function is what? F of x is equals to sine square x. So here f of x is equals to sine square x. So we'll find f of minus x. If we get it to be equals to f of x, then the function will be even. If we get f of minus x to be equals to minus of f of x, then the function will be odd. Okay, so f of minus x will be equals to sine square minus x, that is sine of minus x whole square, right? Now sine of minus x is equals to minus sine x, but because of that square, you'll ultimately get the same answer, that is sine square x, which is equals to f of x. So the function f of x is what kind of function? Is even. And if it's an even function, then the given integral will be equals to what? Twice 0 to a f of x dx. So you integrate this, you'll get the answer. Okay. Now how will you integrate integration of sine square x? We have done in indefinite part, right? So sine square x, we know 2 sine square x is equals to 1 minus cos twice x. So sine square x will be equals to 1 minus cos twice x by 2. So 2, 0 to a, 1 minus cos twice x by 2. So 2 and 2 will get cancelled. You have to integrate only this part. So integration of 1, that is equals to x, minus integration of cos twice x will be equals to how much? We know integration of cos x is equals to how much? Sin x, because ddx of sin x is equals to cos x. So integration of this will be equals to sin x, but x is equals to how much here? Twice x, right? That means along with x, whichever constant you are getting, that has to be divided. limit is from 0 to a. So at the end you substitute the value of the limit. So upper limit is equals to a. So a minus sine twice a by 2 minus 0 minus sine 0 is equals to 0. So a minus sine twice a by 2. Now here the value of a is equals to how much? The value of a is equals to pi by 2. See, the question, the property was minus a to a f of x is equals to twice 0 to a f of x dx, provided the function is even, but the value of a is equals to pi by 2 here. So directly you can substitute here itself pi by 2. A is equals to pi by 2. Pi by 2 here again. So a is equals to pi by 2 minus 2 into pi by 2. So 2 into pi by 2 means sine pi, and we know sine pi is equals to 0. Hence your answer will be equals to how much? Pi by 2. Okay students, I hope till this all the questions are clear. So students, the next one is integration of minus pi by 2 to pi by 2 sine to the power 7x. Again, this is of the same one which we have done just now, okay? That is of the form minus a to a f of x dx. So in this case what you have to do, you have to check whether the function is even or odd, okay? So let's check that. So here f of x is equals to sine to the power 7x. So f of minus x will be equals to how much? Sine of minus x whole to the power 7. Sine of minus x is equals to minus sine x, but since you are getting odd power, hence what will you get the answer? You will get the answer to be equals to minus sine to the power 7x. Right students? And this is equals to how much? F of minus x. So f of minus x and f of x, are you getting it to be equal? No. So f of x is equals to how much? Minus f of x. So this is minus, okay, I'll write it here itself. So f of minus x is equals to minus f of x. Hence the function. So you'll write hence the function f of x is odd. And if you get an odd function, then the value of the integral will be equals to how much? 0. Hence 0 is the answer. So you see students, if you know the property, it becomes very easy for us to get the answer, okay? Now moving on to the next question, that is number 16. Your question is 0 to pi log of 1 plus cos x. So it is again of the form 0 to a f of x. So it will be f of a minus x here. Okay, so 0 to pi log 1 plus cos pi minus x. So cos of pi minus x, that is equals to what? Cos 180 minus x. Cos 180 minus x means it will lie in which quadrant? Second quadrant. And we know in second quadrant cos is negative, right? So this part will be equals to how much? Minus cos x. So cos pi minus x will be equals to 1 minus cos x dx. Okay. Next you have to integrate this. Now how will you do that? 1 minus cos x is equals to what? We know 2 sine square x is equals to 1 minus cos twice x. But here along with x the coefficient is 1, right? Not twice x. So if you write this to be equals to, if you take the angle to be equals to x by 2, then you'll get how much? 1 minus cos x. Right students? So this part will be equals to 0 to pi log 2 sine square x by 2. Now here we will apply property of log. Log AB is equals to what? Log A plus log B. So log 2 we know, hence you have to find the integral log of sine square x by 2, right? So this is equals to 0 to pi log 2 dx plus 0 to pi log sine square x by 2. That means sine x by 2 whole square. And we know log a to the power m is equals to m log a. That means from here you will get 2 log sine x by 2 dx. Okay. Now the value of this integral we know already. We have to find the value of this, the second integral. Okay. So let this be equals to I1. So we will find the value of I1 now. So I1 is equals to 0 to pi this 2, I am writing it here, okay. So 0 to pi, hence it will be equals to 2 I1 then. log sine x by 2 dx. Next, we'll apply substitution method. So let x by 2 is equals to some u. Then du will be equals to half du half dx, and hence twice du will be equals to dx. Now, since you are applying substitution method, so don't forget to change the limit. So when x is equals to 0, u will be equals to 0 again. When x is equals to pi, u is equals to how much? Substitute here, you'll get pi by 2. Hence our given integral I1 will be equals to how much now? 0 to pi by 2 log sine t, not t, at x by 2 we have taken it to be equals to u, and dx is equals to how much? 2 du. 2 du. So twice 0 to pi by 2 log of sine u du. This part will be equals to minus pi by 2 log 2. And how will you get that? So students, you go through example 36 that is given in page number 346. There the value of the integral 0 to pi by 2 log sine x dx is given. So go through each of the steps, you will get to know how we got the answer minus pi by 2 log 2. Okay students, example 36, note it down. So you'll get 2 integration of 0 to pi by 2 log sine u du will be equals to same here, because the first property there I have mentioned that be it the function be it in x or t, you'll get the value to be equals to same. So from here you'll get minus pi by 2 log 2, 2 will get cancelled, you'll get minus pi log 2. So we got the value of I1, which you will substitute it here. Okay, so I will be equals to integration of 0 to pi by 2. Okay, this is equals to 0 to pi here. Okay, 0 to pi log 2 integration of log 2 dx. So log 2 integration of 1, that is equals to x, and put the value of x to be equals to how much here? Pi. So you'll get log 2 multiplied by pi, and the value of this is equals to how much? Minus pi log 2. So minus 2 pi log 2. So log 2 you take common, pi minus twice pi, that is equals to minus pi. Hence your answer will be minus pi log 2. Okay students, this question is important, put star mark. Okay, now moving on to the last question of this exercise. So the last question is, show that integration of 0 to a f of x dx is equals to twice 0 to a f of x dx if f and g are defined as, okay, the value, that is the definition of the function fx and gx are given. Okay, so you have to show that this left hand side is equals to right hand side. So let's proceed then. So integration of 0 to a f of x gx will be equals to how much? Apply the property. So you'll get 0 to a, x will be replaced by a minus x, right? F of a minus x, let this be equals to I. Okay, let this be equation 1. So f of a minus x ga minus x dx. Now substitute the value of f of a minus x ga minus x from here. That is the thing which you have to do. Rest is same as before only. So f of a minus x is equals to f of x, and g of a minus x, you'll get the value from here. Okay, here you do one connection. This part will be equals to g of a minus x. Okay. So g of a minus x will be equals to how much then? 4 minus g of x dx, and let this be equation 2. So adding 1 and 2, you'll get twice I, left hand side I plus I, that is twice I, will be equals to how much? You see f of x dx will get deducted with one of the term here, that is fx into 4 minus fx dx. So it will get cancelled, hence you are left with only 0 to a 4 f of x dx. So 2 and 4 will get cancelled, and hence you will get I to be equals to 0 to a thrice f of x dx, and what is I? I is this. Hence left hand side is equals to right hand side. That is proved. So students, with this we have completed this chapter, that is integrals. It was a very lengthy one. So you go through all the exercises and each and every questions you practice, because all are of different patterns, right? And after that, if you have any doubt, then do share with me. We shall discuss in our Zoom class. So I end today's class. Thank you. Stay home, stay safe.